Good morning, all, and it's a pleasure to be here. I am Varun Tiwari, and I'm working as a remote sensing and geoinformation analyst at ICMode. And it's been 3 years since I'm using Google Earth Engine. And today I'm going to present my work on operational wheat zone area mapping for Afghanistan using harnessing the power of Google Earth Engine and cloud, Sentinel data. Uh, So the most elite thing about this project is the use of Google Earth Engine, and it's the state-of-the-art project that we did along with NASA and USAID for Afghanistan. To start with, let me introduce Afghanistan. It's a landlocked country between Pakistan, Turkmenistan, and Iran. So basically, it's an wheat deficit country, and they have to import the wheat from their neighboring countries. So they actually depends on the neighboring country for their import. And if you see the graph, like here, in past few decades, the production of the wheat has been declined in Afghanistan, with
Varun,
subsequent.
if you're sharing screen, you can do that if so that users can see the graphs. We have also shared the link to the docs to the slides in the YouTube live chat. So any of you all can follow along with what's going on through that.
Yeah, I think now it's visible, right? Just to
Not
be.
yet. Not yet.
Is it visible now?
Are you using the screen share button top left of your screen?
Yeah.
There's another screen that pops up saying that you have to.
1 second. Yeah. Now it is visible, I guess.
You got it now. Yeah. Go
Okay.
ahead.
Yeah. So as I told you, Afghanistan is a landlocked country. It shares its border with Pakistan, Turkmenistan, and Afghanistan, and it's basically a wheat deficit country. So there is a requirement to assess the wheat zone area so that they can plan and implement their policies related to food procurement. If you see the graph on my right hand side, the production of the wheat in Afghanistan has declined in past few decades, which subsequently increase in the imports and the price. This is from FAO report published in 2016, which says there's a significant increase in the import of the wheat from neighboring country. Therefore, there is a strong need of assessing the wheat area so that they can plan how much to import and export and other food related policies. So how we started this project? We started with an consultation workshop, which was held in ICMOD headquarters in Kathmandu within Surveyor HKH initiative. So let me tell you about Surveyor, what Surveyor is. So Surveyor means to serve. It is a joint initiative between NASA, USAID, and ECMOD, which primarily aims to connect space from village, and it's basically a demand-driven program. So the demand came from Afghanistan after this consultation workshop to do some kind of wheat estimates. So that's why we decided to take up this project as a part of survey initiative. So we form a trio team between ECMOD, NASA, and Ministry of Agriculture Afghanistan. The main responsibility of ICMOD is to actually design the framework for wheat zone area assessment. The NASA responsibility is to endorse the methodology, give us technical advice and all. And the main task for Ministry of Agriculture is to supply the ground control points needed for training and validation, and they are also the part of validation team to validate those wheat zone area maps. So why crop area estimation is important for Afghanistan? So if you have the crop area estimates, you can easily forecast yield, and from that you can actually forecast the production, how much is going to be production for a particular year. Now you have, if you have the production, then you can decide the pricing, like what price should I keep for this year for a particular crop. Based on that, you can decide how much to import or export if there is a wheat deficit or surplus. Based on that, these kind of decisions you can take. And others are formulation and implementation of food related policy related food procurement. And the last thing is transportation and storage. Now, if I say my northern part of the country is having more production than southern part, it doesn't defies logic if I am building all my storage capacities in southern part, right? So these kind of planning you can do in advance. That's why the crop area estimation is very important. When we started this project, we faced a lot of challenges in terms of data availability, in terms of requirement of IT infrastructure for data processing, in terms of cloud cover because optical fails. So these are the key challenges that we encountered while uh, framing up the methodology. First thing is the availability of high resolution satellite data sets. Second is smaller field size. So this we have encountered using Sentinel-2 data, because multispectral data. It was launched in 2014, but it was not stable in 2016. But eventually it got stable, so we decided to do that. Another thing is when we were designing this framework, we found that in Afghanistan winters are rainy, so you will not have the optical coverage. So we use Sentinel-1 also, which is in microwave data, and it has a capability to penetrate through clouds. And other problem challenges that we face are limited speed for downloading in Afghanistan, since internet is not good in Afghanistan, requirement of high-end workstation processors and computers, and the availability of manpower that is also lacking in Afghanistan. So we decided to do it in an Earth Engine environment, so that you actually don't have to download data and everything will be done on the fly. And for the people who don't know coding, we can come up with a user interface along with the manual, so that they can use it for their for wheat zone area mapping, and that is also important for the sustainability of the project. So let me show you the status of cloud-free optical images for Afghanistan. So this is the status for Sentinel-2, and you can see it's for the entire growing season of the wheat from November till July. And you can see that the coverage is very less in January, February, March, and April month. Most of the images are cloudy, and you cannot use it for wheat area assessment. On the other side, like SAR has got the capability to penetrate through clouds, where you have coverage for the most cloudy months, the full coverage for the whole cloudy months. So you can complement radar where your optical data is not available. The data sets that we have used for this study is Sentinel-2 and Sentinel-1. Along with that, we have used crop calendar from Food and Agriculture organizations. And then we have also used agriculture math from land cover, because to make sure we are detecting different crops from agriculture area only. And last but the most important is field data, basically the ground locations from different crops that is required in our approach. And in some areas, because the security situation is not good in Afghanistan, it is very difficult to go on field and collect the data. From the provinces where we have worse security situation, we have ordered high resolution digital globe image and PLDAS image for identifying the crop and generating the ground control points for training and validation. This is the methodology that we have used. I'm not going into the technical details. Just want to give you an overview, an idea about how we have framed the methodology. First thing is the data preparation stage, where we have collected the data from the ground from different crops, and then we also have collected some data from high resolution satellite image from different crops. Then we did some quality check based on phenological assessment, and we come up with a two data set. One is used for training, and the other one for validation. Then in the second stage, we use Sentinel-2 optical data and we did some kind of time series analysis for finding out the phenological pattern for different crops, specifically wheat. And based on that, we decided to have seasonal threshold value for 3 seasons: sowing, peak, and harvest. And then after that, we find out that some of the crops have same phenological pattern. So and those are classified as wheat in the previous marks. So we decided to, in the third stage, we decided to do the analysis based on SAR data. So we use machine learning algorithm like random forest and the ground control points to classify time series data. And in the last stage, we did some validation, whatever on whatever maps we generated, and the area estimation. So for doing that, we need to analyze the phenological pattern. So you can see on the first graph there, these are the phenological profile for different crops in Afghanistan: wheat, vegetable, opium, poppy, tree, vineyards, and barley. And you can see there's a high overlap between poppy, barley, and wheat, which can be overclassified in some cases. On the second graph, you can see the how the phenological pattern of wheat varies across the Afghanistan in different agroecological zone. So you can see there is a phenological shift, specifically in the northern areas, the colder regions. We have late sowing and late harvest, whereas in the central part, which is like warm, we have early sowing and early harvest. And in the second part, you can see the phenological response from SAR data, that is backscatter versus time. And you can see the things which are not separable in using or by using optical data, which can be separated by SAR data. So you can see the phenological pattern of wheat and poppy, and they have different backscattered response across the time. These are the results and discussion results from different province, mainly for irrigated and rain-fed field from some of the districts from Afghanistan. And we also did the comparative analysis of using a particular data set at particular time. Like we use 4 combinations. One is optical at mid-season, optical plus SAR at mid-season. Then if you estimate the wheat at end of the season after harvest using optical, or by using both the combination optical and SAR. And you can see that the best accuracy can be achieved at the end of the season, that is 93.98% for Afghanistan, for Kabul. Whereas the decent kind of, if you use both optical and SAR, and a decent kind of accuracy can be achieved if we use at the mid season, if you use optical and SAR both, which is like 86% with 17,466 hectare of wheat. We to test the robustness and the aptness of the algorithm. We also did it for 2 years, for 2017 and 18, and we found that agriculture, I mean wheat area status are more or less same, which have a very little deviation. That also shows that the aptness of the algorithm, or the robustness of the algorithm, or the consistency of the algorithm. This is the status of the wheat for the different provinces. The overall accuracy we got is 83.8% and 89% for irrigated and rain-fed wheat respectively. And here it shows the kappa stats and other accuracy assessment parameters used for assessing the accuracy, users and producers accuracy, etc. Uh, Now, in what we face is, like in government, people don't like coding stuff because they are not programmers. So they need some kind of user interface so that they can run their system by their own. It doesn't require any coding skills. So we come up with 4 modules, which soon we are going to make it public also. Which I'm using these 4 modules, you can actually map the wheat area in Afghanistan, or it is actually generalized. You can also use it for India or any other part of the country. This is an application that we created for Afghanistan. It's based on Google Earth Engine and Python framework. So this is actually the application where you can have the statistics from irrigated wheat and rain-fed wheat. You can also have the flexibility to select any of the province. Say if I'll select Kabul, then you can have, like in Kabul we have 13,000 hectares of wheat and we don't have any rain-fed wheat. You can export the results in different format also. And one more thing is, if you click on this link, um, you can have the information about the metadata that is there for this data sets. You can go through it. It gives you information about what kind of approach we use for validation, what methodology that was used for this project. And we also have one information sheet which is also published, which gives you more idea about the methods used for the wheat area assessment. Um, then this is the conclusion and way forward for this exercise. In the end of the presentation, we were able to conclude that synergistic use of optical and SAR data have shown its potential in mapping wheat zone area in Afghanistan. And SAR can compensate or complement optical data in case of clouds. And Google Earth Engine has proven to be a vital tool for processing large scale mapping or large volume of data sets. In this exercise, we have actually processed more than 10 terabyte of data sets for entire Afghanistan, that too in a time series manner. And the way forward is coordination with MAIL, Ministry of Agriculture, for better planning of field data collection for next year, because it's a never-ending process. Collaboration with UNODC for poppy GCP, because poppy or opium are grown in very restricted areas or those areas which are not safe to visit. But UNODC has some mechanism to collect the data, so we are in collaborating with them to get those GCP so that we don't have any overlap between poppy and wheat. The use of mobile application for data collection and quality control, improvement of the methodology based on lesson learned, update of crop marks, because every year we have a system called regional land cover monitoring system, which actually gives you idea about the gives you land cover for each year. So this year we are again going to update the agriculture marks and do the analysis for this year. And then the capacity building is very important, because if you don't build their capacity, then the sustainability will not be there, and the project will end. And we want that, and someone should adopt this system and do their analysis by their own, so that the sustainability of the project is there. And if the project is no more, then they can continue by their own. This is from my side. Thank you very much. Over to you, Greg.